Hello everyone. In this video, we will see the explanation and also the implementation of train travel question that came in Marathon October 20. Let's see the question. So, Rose is really fond of traveling and this time she decides to travel through a train. Now she is on the train. The train consists of n carriages and the strange thing about the train is that carriages are not of same length. The length of ith carriage is AI meters. The distance between carriages can be neglected. So you can think of it a normal train where the carriages, the length of each carriage is not same. It can be different. Some carriage will be of 5 meters, some carriage will be of 10 meter, and it can be like that. Okay, and the distance between two carriages can be neglected. So what's further? The Rose noticed that the music is being played in some of the carriages. The train is approaching a railway tunnel which is h meters long. Rose does not want that at some point in time only carriages in which there is no music appear in the tunnel. So what this statement is telling that there is a tunnel. You can think of a tunnel, that there is a tunnel. This is a tunnel in which and its length is h. Okay, and its length is h. And a train is coming and approaching, and the train with different length of carriages is coming and is approaching this tunnel. So what does Rose does not want that at some point in time only in which there is no music. So as given in the example, you can see that as given in the example that it will be represented if in the carriage, if it will be represented, if it is 1 then the music is being played in that carriage, and if it is 0 then music is not being played in that carriage. So when the train is approaching, then at that time if the some part also of the carriage is present here, if the some part also of the carriage is present inside the tunnel, so at that time music should be on. At that time, this is what this line is saying, at that time music should be on in the tunnel. Suppose if the train is covering this whole thing, then in the tunnel music should be on, that there should be at least one carriage which where the music should be playing. There should be at least one carriage if it the whole this tunnel is being covered. And if it is approaching in the tunnel, then at time too there should be that music should be on, because at time that the because the moment of silence will occur if the also the some part of the carriage is present and music is not playing. So this is what the question is telling to us. Now let's see and let's try to understand this question, because what we have to find, that we have to find that here it is given that the Rose turn on the music in the minimum number of carriages. Help Rose turn on that we want to know that the minimum number of carriage in which we can play the music, so that the no moment of silence occur in the carriages, no moment of silence occur while the even the some part of the carriage is present in the tunnel, the moment of silence is not there. So let's better understand with the help of example. Okay. So this is the example and the important pointers. I have already told you that length of ith carriage is AI and the length of tunnel is h. If the music is on, then it will be represented by 1 L0. This statement I will explain you again with the help of diagram. Suppose, and with the help of this example, taking this example and this diagram. Okay. Suppose this is the tunnel, and now the length of this tunnel is 10. This is the length of the tunnel, and now a train is approaching. Okay, you can say a train is approaching. A train is approaching where it has different carriages. First carriage is of 5 meter, second carriage is of 3 meter, third carriage is of 4 meter, and fifth again fifth kilometer is 5, and uh, fourth is of 5 meter, and rest of all are 9 meters. You can see there. And where the music is being played, music is being played here at this point, at this point, and this point, and this point music is not being played. In this point, in this carriage music is on, and in this and in this music is off. Now when this 5 will approach in this train, what's the 5? When the 5 is approaching, then there is some part of the carriage when that is present inside the tunnel. At that time the music should be on. That's what the question is, that there should be no silence. There should be no silence when even the some part of the train is the present, some part of this carriage is present inside the tunnel. So when 5 will approach, suppose when 5 is approaching, suppose this is the tunnel, and now 5 has been approached here, Here it is 5. It is 5 present here, and at this time we will check whether the music is being played or not. Yes, music is on, so we will not on the there is no need to again on it. It is on only. Now when 3 will occur, what is 5 plus 3? 5 plus 3 is equal to 8. So it will take something here. This will be fifth carriage, and this will be third carriage. Okay, music is playing here, music is on here, and music is off here. So is there any problem? Because there will be no silence, because there is no silence, because there is one carriage where music is on, so there is no need of we switch on this tunnel or switch on this carriage, because there is a carriage where the music is being played, and that carriage is present, some part of that carriage is present here. The whole box is present, the some part of that carriage is present inside the tunnel. This is what the question is saying. Now what we want to check, for fourth one. Let's check for the fourth one. This is the tunnel, and what is 5 plus 3 plus 4? It is 12. Now 12 is exceeding 10. 12 is greater than 10. So the some part of the 5 will be outside, and some part of the 5 will be inside, and 3 will be completely inside, and 4 will be completely inside. Now, do we need to on any carriage? Because here the music is on, here the music is not on, here the music is not on. So can you see the silence zone in the tunnel? I cannot see, because in this carriage fifth with this length 5, and it is some part of it is present in the tunnel, and where the music is on, so there is no need to turn on the music. Okay, so there is no need to turn on the music. Now let's say this 5 occurs, this 5 completely pass. Now 3 plus 4 plus 5, what is the distance? 3 plus 4 plus 5 will be your again 12. Now some part of the 3 will be outside, you can say, and this is a tunnel. This some part of the 3 is inside, 4 is completely inside, and 5 is completely inside, you can say. Now music is neither it is on here, neither it is on here, neither it is on here. Now the question is saying that there should be no silent zone, and we have got the silent zone. Now we have to turn on the music. Now we can either turn on the music in this place, or we can turn on this place, or we can turn on it this place. So now we have to choose in such a way that if we turn on the music in any of the carriage, the further if we get some problem, we should reduce, because we have to only turn on the music in minimum number of carriages. So we have to select the optimally between these three. So this was the explanation of the question. This was the what question wants to ask to us. This was I was trying to explain the question statement to you, because it becomes confusing that whether to where we have to turn on the music, and where we have to turn off the music, where we have to check and where we have to not. So this was the whole scenario, that you can think that while approaching we have to check, while it is leaving then we have to check, and while the whole it is captured by the and the whole tunnel is filled by the carriages only, then we have to check that whether there is no silence zone or not. So this was the explanation of the question. Now let's try to build the logic for this question, and let's try to check that what approach we can use to solve this question, and to get the optimal number of optimal to get the optimal move, so that if we apply that, so we have to on the minimum number of carriages, music in the minimum number of carriages only. Let's see that. Okay, what we should think while developing logic. As I have drawn this diagram, that while drawing this I was taking the sum, so you could understand easily that sum will play important role here. So now what the important thing is to think that what carriage we should include in our, what carriage length we should include in our sum, and what carriage length we should not include in our length. Okay, so we can understand from this that if the music is already on the carriage, it's on in the carriage, so there is no need to take that carriage or before that carriage to include that thing in the sum. So while in the beginning only I have told you that while approaching the train, music should be on, because there will be some part of the train will be present and there should be music on. So with this, with the help of this, we can develop this logic. The first case, first case one will be, your case one can be that, the first case can be that your first box, your first carriage, in first carriage, music should always be on. Music should always be on, because it, while approaching here, if the music is not on, if we are not owning the music, if it is off, then this moment of silence will occur. So at this point music should be on, because no matter if the music is off here and music is on here, suppose music is off here and music is on here, so then also firstly this carriage will only come, and at that carriage the moment of silence will occur, at that carriage the moment of silence, so the our answer will become false, it will give us wrong answer. So that time we should check if it's the first carriage, music should always be on. If it is not on, we will do it, and we will increase our counter. Now what should be case 2? What should be case 2? We should have some, and we should include every element in the sum where the carriage is zero, now till when we should include? This is the point. Till when? Like here I was including in this sum, I was including 5 plus 3 plus 4. Okay, so now let's not include this 5 because their music is on, so we will do the sum 0. Now 3 plus 4 and plus 5, until now we have not got anyone, and it has exceed the length of 10. It has exceed or it is equal to, it is greater than, when the sum is greater than or equal to h, and till this point we have not got anyone here. Till this point we have not got anyone, then what we will do, we will just increase our counter. We suppose I am counting with C, we will just increase our counter, and as I have told you that we have to select optimally. So in which carriage we should turn on the music? We should always turn on the music in the last one. Why? Because if the first one will pass, and if the if in this 9 also, if suppose in this 9 also music was off, and if we turn on music here, so if this carriage will pass, we will again need to turn on the music in 9, in the fourth one. Then we'll again, and what we want minimum number of increment. So to avoid that, we will always try to turn on the music in the last carriage, which is lastly present in the. So we will turn on the music here, so that when this passes, then also music is on while some carriages are present in the tunnel. So then also the music is on. So when this 9 will come, whether in this case in the 9, in this length the music is on. But suppose in this case the music is not on, then what we will do that in that case? In that case, there will be no need to turn on the music, because in this in this fourth tunnel, 1, 2, 3, 4, 5, 6, 7, in this fourth carriage, the music is, we have turn on the music. So what I want to say that we will include in our sum. We will, if we can say this, if of M, we can take this array as of M, okay, music, and take this array of A, okay. If M of I is equals to your 0, so what we will do, we will do simply is equals to A of I. And what we can do, at the time when the sum is greater than equal to 0, greater than equal to H, then we will simply increase the counter. And in beginning only we will check for M of 0. If it is 0, we will increase the counter. We will simply increase the counter. Counter increasing means that we are turning on the music. We are turning on music in that carriage. Okay, and we will traverse only in one loop, because and we can do this question in only one loop. So there is no need to turn on the music and check that, because there will be no checking of the previous carriage. Okay, now what the case can also occur? What will happen if this is the tunnel and this is the train? Okay, this is a train carriage 1. Here music is not playing. Train carriage 2. Here music is not playing. And train carriage 3. Here music is not playing. We have turned on this music. Okay. Now again carriages come. And now we have turned on this music. Now suppose this time it is this situation occurs. That this tunnel was on and this was not on. So we are getting here that there is no need to turn on the music, but we have included in this our sum. Okay, suppose it is 3, it is 4, it is 5. So at this point sum was our 12. Now we have turned on the music and it is 2 and it is 6. Now 12 plus 2 is also equals to 14 and it will be greater than equal to 10. So it will again increase the it will again increase our count. So how to avoid this count? How to avoid increasing, because there is no need of the increasing the count. So we will check that if of m of I is 1, then we will simply do sum is equal to 0. We will again begin from the scratch. Again, we will start counting from the scratch. We will again starting including from the beginning. So this was the second case. This completes are the second case and first case. Now only one case is left. I want you to pause the video and just think of that edge case. Just think for a few seconds of that edge case. Okay, I think you must have thought what was the case 3 here, that what will happen if all the carriages have passed and only the last carriage is left. If all the carriages passed, only the last carriage is left, and if it is not playing music here, and here above this carriage music was playing, but in this music was not playing, what will happen? The moment of silence will occur. So what we need to do, we need to turn on the music. So what we will check, in beginning only, that if r m of n, you can say that n is length of array, is equals to 0, then we will simply turn on the music. We will simply increase our counter. So these were the three cases that was important in this question. That was important in perspective that we have to look. Otherwise, it's a simple question. We have to only just count the sum here, and whenever the sum will exceed our h, that is the length of tunnel, and at that point, till that point, we are not getting any carriage where the music is being played. So we will simply increase the count at that time. Or else, what we will do, if our here with this example I have told you that why I am doing this m of I equals to 1, why I am doing this sum is equal to 0. So at that time because there is no need, if we will not do this sum is equal to 0 and the other tunnel, it will added again back to the sum that was previously 12, and it will again increase the count, and there is no need to again increase the count, because here in this case there is no need, because we need at least only one carriage. If this is present where the music is on, then there is no need to turn on the music. So this was the approach that we can use to solve this question. To check this question, the only important in this question was these two edge cases, to check the approaching, the when the train is approaching, when the, you can see the this edge cases uh, when the first carriage is approaching, and this will be the second edge case when the last carriage is leaving the tunnel. At that point music should be on. The rest of the time we can do this thing, and we can get other count. Okay, now let's see the implementation for this question, and let's see that how we can implement this question, how we can implement these cases in the code. Okay, let's see that thing. So here is the code for this question. Here basically at this point I am taking the input of test cases. As you can say, firstly we will take test case, then I am taking input for your n, that is number of carriages present, and h, that is the height of the tunnel, distance of the tunnel, you can say total. And then I'm taking input in this array A and this array M, which will denote that music is playing or not. And then simply I'm checking for edge cases that I have told you earlier also. In the earlier also I'm checking. This is firstly we will check if M of 0 equals to 0. Then we will turn it on, and we will do M of 0 equals to 1, and we will increase our counter by 1. Okay. If M of n minus 1 equals to 0, then M of n minus 1 we will do it 1, and we will increase our counter. Now, why I am increasing here and I am not increasing here? Just think that, but why I am not increasing, I am changing the value of m here, I am not changing the value, because I am traversing here from 0 to n, and it will again add the sum if it is making it if it is 0, and it is also increasing the counter. That means this here music is playing on, and it will again check for m of 0. For that, to avoid that case, I'm doing this thing, m of 0 equals to 1 and m of n minus 1 equals to 1, the same reason, because it is traversing from 0 to less than n. And at that time also, I'm checking the case 2 that I've told you, that if sum is greater than equal to h, we will simply increase the counter and do the sum is equal to 0. And we can do that. So we, every other time we can just increase the add the value of that carriage at the length of that carriage in our sum. Else, what will be the else condition? Only else condition will be that m of I is equal to 1. If m of I is equal to 1, we will make our sum is equal to 0, because there will be at least one carriage where the music will be playing. So at last we will just print up C, and this will be our answer. So this was the explanation and the implementation of this question. Hope you would have been able to understand this question. Thank you for watching.